geometric series.
So I think your board is like flipped the wrong way for me.
Oh, yeah, it is. Give me 2 seconds. There, sorry. Okay, so geometric series. So a geometric series is a series of the form so it's like this. Sum n is equal 0 to infinity a times r power n. That's a geometric series. So it's a number times a number power n. And this series, so there's two things. To decide if it converges or diverges, you will look at your R and you will find the absolute value of R. Okay? If the absolute value of R is greater or equal to 1, or if the absolute value of R is less than 1. Okay, so if the absolute value of R is greater than or equal to 1, then the series diverges. Okay, divergence means that it doesn't approach to a certain sum. But if it is less than 1, then the series converges to, okay, it converges to a certain value, which is a over 1 minus r. So example 1, we'll start with easy ones and slowly make them a bit more complicated. So example, let's say 1, okay. First series, let's do sum n equals 0 to infinity of 3 times 1/2 to the power of n. Okay, so does this converge or diverge? And if it converges, to what does it converge? Second example, sum n is equal to 0 to infinity 2 power negative 1/3 power n. Example 3, sum n 0 to infinity 5 times pi over 3 to the power of n. Here we go. Let's start with these three. What is this one? So R is 1/2. 1/2 is less than 1. Therefore, this series converges. Good? So it converges to A, which is 3, over 1 minus R, so 1 minus 1/2. And that gives you 6. Okay, so this series approaches 6. Easy enough? Okay. This one here, A is 2, R is negative 1/3. Negative 1/3, the absolute value is 1/3. That's less than 1. Converges as well. Converges to A, which is 2, over 1 minus R, 1 minus R, which is negative 1/3. Okay, and so we get 2 over 4/3, which is 6 over 4, which is 3 over 2. So this converges to 3 over 2. Any questions? This one here, yeah,
Sorry?
yeah.
Does A always have to be a constant?
What could it be?
Like, let's say, uh,
An expression with n's, you mean?
yeah, let's say.
Okay, no, it's a good question. No, it has to be a constant.
Okay.
Okay, if there's an n here, it becomes more complicated. Okay, it really, really has to be in this form. A number times a number power n. That's it. This one here, what is it? Can you tell me? Anyone?
It diverges.
Very good. Okay, so you might be tempted to do 5 over 1 minus pi over 3, but doesn't work because pi over 3 is bigger than 1, so it diverges. Okay, diverges. Okay, since, well, the absolute value, I don't care about the absolute value here because it's positive anyways, but just to write exactly like I wrote it, because the absolute value here of pi over 3 is greater or equal than 1. So it diverges. Okay, any questions? Okay, let's increase the difficulty a bit. Example 4. Sum n is 0 to infinity. Let's say 2 power 1 minus n, 1 minus 2n, sorry, times 3 power n. Okay, so this is a little more complicated because it's not in the form a r power n. Okay, but we're going to have to play around with the exponents here and rewrite it into the form that we know. Okay, we always have to have the form that we know to apply this formula here, which we're going to prove shortly. Okay, so this is equal to sum. So here's a little work to do. So 2 power 1 minus n minus 2n is 2 power 1 times 2 power negative 2n times 3 power n. Okay, this is like 2 power 1, right? You add the exponent, 1 minus 2n, 1 minus 2n. This is the same thing as sum n is 0 to infinity, 2 times, so power 2n, I could send it downstairs. So it's 3 power n over 2 power 2n. equals sum and 0 to infinity 2 times, so 3 power n, and 2 power 2n is like 2 power 2 power n, which is same thing as 4 power n. Okay, let's keep going here. Continue here. Is equal to sum and 0 to infinity 2 times, and I could combine them into one fraction, 3/4 power n, and now I recognize my form. Okay, a r power n. And so the r is less than 1, right? The absolute value of r is less than 1, so it converges to a, which is 2 over 1 minus r, which is 3/4. And so my answer is 8. Example 6. So sum n equals 0, goes from 0 to infinity. 3 power negative n times 2 power 3 plus n. So this is equal to sum and 0 to infinity. So 3 to the negative n times 2 power 3 times 2 power n. This is, so this one is easier than the last one. 0 to infinity. So 2 power 3 is 8 times 2 power n over 3 power n is 2 over 3 power n. And so you should have gotten 8 over 1 minus 2/3, right? The r is less than 1. And you should get, I think, 24. Is that okay? That's what you got?
Yeah.
Okay. Okay, good. Okay, let's complicate things a bit. Example 7. So look at this one now. Sum, oops. And goes from, so let's start at 1 now. 1 to infinity. Let's say 3 power 2 minus n times 2 power 1 minus n times, let's say, 5 to the power of n plus 1. Let's just do one thing here. I'm going to do minus here. I'm going to do 1 minus 2n. Okay. There you go. Okay, so this is a little more complicated for 2 reasons. First of all, here I don't have the form that I know, a r power n, I don't have it. And second is that it doesn't start at 0 anymore. Okay, my formula, right, my identity works when n starts at 0. Okay, so the first thing I should do is I should make it start at 0. And how do I do that? Okay, so listen carefully. You will do one right after. So we start it at 0 as follows. Sum n equals, I'm going to put a 0 instead of a 1. Okay, but now every n, I need to add 1 to it. Okay, because my first term here is when n is 1. So here, my first term has to be when this position is at 1. So I need to add 1 to the n. Even same thing here. 2, 1 minus 2 times, the n becomes n plus 1, and this n also becomes n plus 1. Okay, so that's your first step, is to make it start at 0. Okay, if it started at 5, then you would put a 0, and every n you would do n plus 5, n plus 5, n plus 5. Is that okay? Okay. Sum n equals 0 to infinity. So let's simplify this. I have 2, sorry, not 2, sorry, 3 to the power of 2 minus 1, so it's 1 minus n, times, here I have 2 to the power of, so 1 minus 2 is negative 1 minus 2n, times, and here I have 5 to the power of n plus 2. All right, although enough space to finish. I'll write a bit smaller here. So sum n equals 0 to infinity. So here we go, 3 power 1, 3 to the power of minus n, 2 to the minus 1, times 2 to the negative 2n, times 5 power 2, times 5 power n. And that is equal to sum n 0 to infinity. So 3 times 25 over 2. So 75 over 2 times, and here I have on top 5, and on the bottom 2 power 2 times 3, so 4 times 3 is 12. That's what you get when you simplify. Okay, and now I have my form. It starts at 0, a r power n. The r here is less than 1. We're good. So this converges to, I'm just going to write up here because I'm out of space. So 75 over 2, which is a, over 1 minus 5 over 12. Okay, so whatever that is, I don't know what that is, 6, 12, 7, 6, 6 times 75 over 7. I don't know what 6 times 75
Sir.
is. Yeah.
For the 2, it's you put -1, but there it's 1 plus 1. So I was just wondering how you got the
Sorry?
negative. Because for the 2,
This minus 1 here?
yeah.
Okay. Well, we did 1. Oh, you think minus 1 here?
Well, that's a plus, no?
No, but there's a minus 2 here. Minus 2 times n is minus 2n. Minus 2 times 1 is minus 2. You have to distribute here the minus 2.
Oh, you're multiplying.
Yeah, here it's a times.
Oh, okay. I didn't know you were multiplying. Okay.
Okay. So 75 times 6. So it's 4. I get 450 over 7. Okay. You could double check. I'm not sure.
Yeah, that's the answer.
The answer? Okay,
Yeah.
perfect. Perfect. So this is example 7. Example 8. Okay, so try it out. Let's do sum n equals 2 to infinity. Let's do 2 power 1 minus 3n times 3 power n plus 1 and minus, no, sorry, not minus, sorry, times 4 to the power of negative n. Okay, so let's just put a 3n here. Okay, 3n plus 5. Okay, go for it. Okay, so we started at 0, like I said before. So sum n equals 0 to infinity, and every n will now become n plus 2. So 2 to the power of 1 minus 3 times n plus 2 times 3 to the power of 3 times n plus 2 plus 1 times 4 to the power of negative n plus 2. Okay, so this is your first step. Any questions on this step?
Why did the n go from 2 to 0 on like the sum of sign?
Sorry?
Why did the n go from 2 to 0 on the sum of sign?
Oh, okay, you just got to class?
Yeah.
You missed the whole beginning?
Yeah, my internet
that's-
wasn't.
Okay, so that's why, because so I have to re-explain. You have to know that we have a form. Okay, just a reminder. It's we're doing geometric series, and the geometric series is like this: a number times a number power n. Okay, and this series here has two possibilities. If the absolute value of r is greater or equal than 1, then the series diverges. And if this is less than 1, if the r is less than 1, then it converges to a over 1 minus r. Okay, so we didn't prove this yet, but that's what we're doing. Okay, so this series, it is a geometric. I'm sparing you the stress of recognizing that it's geometric. So I'm just telling you that it's geometric, but eventually you have to recognize it. Okay, so the first thing you need to do is you have to make sure that it starts at 0. So for you to be able to use this formula. Okay, so we have to make it to 0. In order to transform this to 0, I need to, since I went from 2 to 0, every n, I need to add 2 to it. Okay, if it started at 7, you would start at 0 here, and you would do n plus 7. You add whatever you took off here. Okay, I'm just summarize it quickly, but look at the video after, and I went really slow. Okay, it's going to be clear. Okay, at this point now we have to rearrange this until we recognize this form. So let's go. Sum. Okay, so already we took care of the n equals 0. So let's do this. 2 to the power of 1 minus 6, which is negative 5, times 2 to the negative 3n, times, this is 3 to the power of, so 6 plus 1 is 7, times 3 power 3n, times 4 to the power of negative n, times 4 to the power of negative 2. Okay, almost done. So the numbers, what do I have in the numbers? 3 power 7 over 2 power 5 times 4 power 2. That's what I have here as numbers. 1, 2, 3 numbers. And the terms that have a power n, what do I have? So I have 3 power 3n over, and on the bottom I have 2 power 3n times 4 power n. Equals sum n equals 0 to infinity. So 3 power 7 over 2 power 5 times 4 power 2. times, and here I will have 27 power n over 8 times 4, which is 32 power n. So that's what I have. Okay, and now I have sum n equals 0 to infinity a times r power n. R is 27 over 32, that's less than 1. Perfect, I can use my formula. And so this will be a so just gonna go like this. So 32, so 2 power 9. Okay, over 1 minus 27 over 32, whatever that is. Okay, so 32 minus 5, so let me just calculate this. 32 to the power 5. 5 times, so 3 power 7 is what? Okay, that's good. 2187 over, and what do I have here? 2 power 4, 2 power 4, 16 times 5 is 80. Perfect. So most of you guys got it right. So let's prove it. Okay, the geometric series has a lot of applications, especially in finance. Okay, you'll see that if you ever study in finance, every mortgage is a geometric series. When you have to pay back your mortgage, to calculate the interest and the principal that you pay back, it's a geometric series. Okay, so let's prove it. So this, I'm just going to rewrite this, sum 0 to infinity a r power n is equal to a over 1 minus r if the absolute value of r is less than 1. Okay, and let's prove it. Okay, so let's find the partial sums. Okay, so when we want to find if a series converges, if you remember, we find the sequence of the partial sums. So I'm just going to write the nth partial sum. No, not n, I'm going to use k, okay, because I already have an n here. So the kth partial sum. So sk will be what? Sum n goes from 0 to k of a r power n. Okay, so what is this actually? If I am to, let's expand the series. So when n is 0, I get just a, plus when n is 1, I get a times r, plus when n is 2, I get a r2, plus, and so on, a r3, plus dot dot dot, all the way until k, so a r k. Is that okay? No questions here? Okay, so this is sk. I need to find an expression for this so that I could do the limit as k approaches infinity. Okay, that's the idea. And I want to show that this limit will be a over 1 minus r, if I can. So what I'm going to do is I'm going to multiply sk by r on both sides, okay? I'm going to multiply sk by r. So r times sk is what? Okay, I'm just going to go here. R times sk is just, if I multiply everything by r, well, I'm going to get ar plus ar squared plus AR cubed, right? I'm just multiplying every term by R. AR4 plus until the last term here will be AR K plus 1. Do you have any questions about this? Okay. At this point, I have SK equals to this, R times SK equals to that. Well, if I minus this side and I minus this side, I'm still getting a valid equality. That's what I'm going to do. So I'm going to minus here. What do I get? I get SK minus RSK equals, and what do I get here? If I do this minus that, well, the AR minus AR will cancel. AR2 minus AR2 will cancel. AR3 cancel, cancel, cancel. Everything will cancel besides for what?
The first one and then the last one.
Very good. So A minus this guy. AR K plus 1. Is that okay? Okay. And yes, tell me.
The A is left, but like the ARK, we don't touch it.
The ARK here
Yeah.
is going to cancel with the term before, which is ARK here. It will cancel as well,
Oh,
right?
okay, yeah.
This is the cancel. Only this one and that one stays. This
Okay,
stays.
perfect. Yeah.
Okay, so here I could extract an SK times 1 minus R equals, and here I can extract an A times 1 minus R to the K plus 1. And that tells me that SK, right, the Kth partial sum is equal to A over 1 minus R times this, 1 minus R to the K plus 1. Okay, so that's very good because now I have an expression for SK and it's very valuable for me. So now the only thing we need to find the sum until infinity, I just need to find a limit at infinity when K approaches infinity here. So limit as K approaches infinity of SK is equal to, so A over 1 minus R, so you recognize already, we're very close, right? Times the limit K approaches infinity of 1 minus R to the K plus 1. Okay, this is 1, and now R power K plus 1. This, if R is less than 1, it goes to 0. If R is more than 1, it goes to infinity. Okay, so this is equal to A over 1 minus R if the absolute value of R is less than 1. Okay, and it will diverge otherwise. Okay, that's our proof.